Something quite odd is happening in the constellation Orion, one of the most visible stars in the night sky, Betelgeuse, which is renowned for its enormous brilliance and massive size, amid the silent great blackness of the universe. Betelgeuse is acting strangely and out of character. For years, astronomers have been both captivated and perplexed by the behavior of this celestial giant, which is considered to be among the most identifiable red supergiants that can be seen from Earth. Betelgeuse has been a lighthouse in Orion's shoulder, distinguished not only by its crimson color but also by being one of the few stars visible to the unaided eye that changes brightness over time. However, recent occurrences have turned this star from a marvel to a mystery. The Betel fluid has started to fade, pulse, and whirl in unexpected ways. Since these actions are not entirely understood, scientists have been forced to ask the shocking question: are Betelgeuse interacting with an unseen, possibly hidden companion in their final stages of life? In order to comprehend why this subject is so important, it's crucial to think about what Betelgeuse is in reality. Despite its brightness and magnitude, something appears to be subtly but persistently interfering with the star's natural behavior. Some scientists believe that this influence may be coming from a secondary body, possibly another star hidden from view by clouds of dust and the overwhelming brightness of Betelgeuse itself. Betelgeuse is a red supergiant, one of the largest types of stars in the universe. If it were placed at the center of our solar system, its surface would extend well beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and our neighboring red planet in its fiery expanse. This notion has sparked a flurry of fresh findings and hypotheses that have the potential to drastically alter our comprehension of the evolution and demise of big stars. Although Betelgeuse has long been known for its unpredictable light patterns, astronomers worldwide saw something unprecedented in late 2019 when the star started to drastically dim, losing up to 60% of its brightness in a matter of weeks. This dimming was so dramatic that some people started to wonder if the star was about to go supernova because red supergiants like Betelgeuse are known to die in violent explosions. This wasn't an unreasonable fear, but further investigation provided a less catastrophic explanation. This massive dimming, as it turned out, wasn't the end of the world, but it did serve as a cosmic wake-up call, demonstrating that Betelgeuse was not as stable as previously believed and that external factors or possibly internal events might be playing a larger role than previously thought. It was most likely caused by the ejection of an enormous cloud of dust that then drifted into our line of sight and temporarily blocked the star's light from reaching Earth. Internal pulsations, which are essentially waves of expansion and contraction that ripple through the star's massive atmosphere, cause Betelgeuse to naturally vary in brightness. These are expected in stars of its kind and are generally predictable, but one specific pattern caught scientists' attention: a secondary longer cycle that repeats approximately every 6 years. This rhythmic fluctuation is unusually consistent and cannot be readily attributed to chaotic processes within the star itself. It suggests a steady repeating influence that could be the gravitational pull of a nearby but invisible companion. This idea led to the compelling hypothesis that Betelgeuse is not alone. Rather, it may be a part of a binary system with a much smaller and fainter star orbiting at a considerable distance, possibly around the same range as Saturn orbits the Sun. If accurate, this would explain not only the 6-year rhythm in Betelgeuse's light, but could also account for other anomalies like its surprisingly rapid rotation. To look into this potential because ultraviolet light can reveal hot low-mass stars that would be invisible in ordinary optical wavelengths due to the main star's glare, a team of astronomers led by Jared Goldberg turned to the Hubble Space Telescope using its ultraviolet spectrograph to search for subtle traces of a hot, faint object hidden near Betelgeuse. Unfortunately, the team was unable to confirm the presence of a companion because the brightness of the surrounding dust and Betelgeuse made it nearly impossible to observe anything directly. However, this lack of visual confirmation did not refute the theory. Rather, it only deepens the mystery. Further observations began to suggest that something, though unseen, is exerting a measurable effect on the star. One particularly perplexing anomaly is Betelgeuse's rotation speed. Given its advanced age and evolutionary stage, it should be spinning far more slowly. Instead, Betelgeuse rotates at a speed of about 5 to 15 kilometers per second, far faster than theoretical models predict. A likely explanation is tidal acceleration just as Earth's oceans are influenced by the gravitational pull of the Moon nearby. Stellar companion could be exerting tidal forces on Betelgeuse, keeping its spin rate elevated. These gravitational interactions might also be disturbing the star's outer layers, leading to the consistent 100-day pulsation observed by astronomers. If a smaller star is indeed orbiting Betelgeuse, its presence could be stirring the massive outer envelope of gas and plasma, causing periodic changes in brightness, shape, and even mass loss. Interestingly, this wouldn't be a rare arrangement. The majority of huge stars form as part of binary or multiple star systems rather than alone. A single red supergiant like Betelgeuse would be the exception rather than the norm. This lends even more credence to the notion of a secret partner. Some scientists have even gone so far as to propose that Betelgeuse may have once merged with a smaller star, which could explain both its mass and fast spin. However, this theory falls short in explaining the ongoing periodic changes that are still visible today, which seem to point to a continuous external influence rather than a single occurrence. If Betelgeuse does have a stellar companion, it may be drastically changing the star's behavior near the end of its life. In their latter stages, red supergiants like Betelgeuse are known to release massive volumes of material. The star characteristics that have been seen recently orbiting Betelgeuse are surrounded by massive clouds of gas and dust created by these mass ejections. These ejections may be caused by a nearby orbiting partner gravitationally upsetting the star's extended atmosphere. What would seem like abrupt, violent mass expulsions might in fact be frequent reactions to the slow but steady pull of a concealed friend. If astronomers can verify the existence of a companion and track how it affects Betelgeuse's light mass loss and rotation, they may be able to better model how red supergiants develop and eventually explode. Understanding this interaction could provide important insights into how supernovae form and behave. It might change the way we interpret data from other dying stars in the galaxy. For example, interactions with a companion may influence a supernova's timing, intensity, and nebula structure, which could have a significant impact on how we perceive the cosmos. If companion stars are crucial in causing or forming these explosions, they may have an indirect impact on everything from galaxy formation to the beginnings of life itself. The physics of supernovas shapes the distribution of heavy elements like carbon, oxygen, and iron throughout space. These elements are the building blocks of planets and life. In the meantime, Earth-based telescopes will continue to monitor the star's light variations, spectral shifts, and 6-year pulse cycles. Future observatories, most notably the James Webb Space Telescope, may finally be able to break through the dusty veil surrounding Betelgeuse and detect the elusive companion, if it exists. Its infrared instruments are well suited to spot faint objects hiding in dusty regions of space. If these trends hold true, they could provide further information that would help us verify the existence of a second star. This celestial investigation is fascinating because it is happening in real time with a star that is visible to the naked eye. On any clear night, one can go outside and look up at the constellation of Orion and see Betelgeuse shining faintly with a reddish glow. It is an ancient volatile star that is carrying secrets within its flickering light. This is a unique chance to observe cosmic transformation as it takes place, whether Betelgeuse is being influenced by a hidden companion, bears the scars of a previous merger, or is going through a completely new kind of stellar evolution. Scientists are now closer than ever to understanding its actual nature, which goes beyond a dying star's gradual fall. It is a dynamic astrophysics puzzle with a wealth of opportunities. When Betelgeuse eventually approaches the end of its existence, it could do so in a manner that changes our understanding of how stars live and pass away. Whatever form it takes, it could rank among the most amazing and illuminating celestial occurrences in our lifetimes from a scientific standpoint.